so what we're being asked to do here is to find the first 5 terms. Basically, so to find the first term, we plug in a 1. To find the second term, we plug in a 2. To find the third term, we plug in a 3, and so on. So to find our first term, we're going to take, so a of n, or in this case, a of 1, is basically saying the first term. So we're going to plug, and basically since I plugged in a 1 for n, we're going to plug in a 1 here. So we have 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7. So we're going to do the same thing for the second term. So we're going to basically replace the n with the 2. So this time we have 2 times 2 plus 5. So 2 times 2 is 4, plus 5 is 9. So then we move on to the third term. So this time we plug in 3. So 2 times 3 plus 5. So that's 6 plus 5 is 11. Then we go to term 4. That's 8 plus 5 is 13. And then the fifth term, we're going to plug in a 5. So 2 times 5 is 10, plus 5 is 15. So these are the answers. 7, 9, 11, 13, 15. Okay, so for number 2, we are finding the first 5 terms again. So we want to find the first term, we plug in a 1. So we're also going to plug in a 1 here. So 3 to the first is 3. So to find our second term, we plug in a 2 for n. So this time we have 3 squared, and 3 squared is 9. To find the third term, we plug in 3. So we have 3 to the third, which is 27. To find the fourth term, we plug in 4. So we have 3 to the fourth, which is 81. And for the fifth term, we plug in a 5. Which is 243. So our answers are 3, 9, 27, 81, and 243. Okay, so here we're still trying to find the first 5 terms. So to find the first term, we're going to plug in a 1. Now there's multiple n's here, so we plug it in for every single n. So we're going to have negative 1 raised to the first over 1 squared. So negative 1 to the first is negative 1. 1 squared is 1. And if we divided that out, that's negative 1. We're going to do the same thing with 2. We're going to plug in a 2 now. Anywhere there's an n. So negative 1 squared is 1. 2 squared is 4. So that one we don't have to do anything to, so it's good. To find the third term, we now plug in a 3. So negative 1 raised to the third is negative 1. 3 squared is 9. For the fourth term, we plug in a 4. So this time we end up with negative 1 to the fourth over 4 squared. So negative 1 to the fourth is 1, and 4 squared is 16. Then to find the fifth term, we plug in a 5 anywhere there's an n. So negative 1 to the fifth is negative 1. 5 squared is 25. Okay, so for number 4, they're just asking us to find the 10th term. So all we have to do is basically plug in a 10 anywhere that there's an n. And the reason we know it's the 10th term is because the subscript here is a 10. So anywhere that we have an n, we're going to replace it with a 10. So we have a of 10 equals n squared, so n is 10, over n squared plus 1. So again, that's 10 squared plus 1. So 10 squared is 100. 10 squared is 100. So we end up with 100, and if we add that, we get 101. Okay, number 5, this time they're asking us to find the 25th term. So anywhere that we have an n, we're going to replace it with a 25. So we have a of 25 equals negative 1 raised to the 25th times 3n, which is 25 minus 2. Now, anytime we have a negative raised to a odd exponent, it's going to be a negative number, so that ends up being negative 1. And then here, 3 times 25 is 75 minus 2 is 73. So if we multiply those two, we get negative 73. Okay, number 6 is asking us to write the rule. So typically, these are our terms. So what I'm going to do below it is I'm going to put the value of n. So like this is our first term, this is our second term, third term, fourth term, fifth term. So what we're looking for is we want to write it in some kind of a way in relation with n that gives us the answer. So one thing that we want to do is we want to see what are we doing going from one term to the next. So going from 1 to 4, we add 3. From 4 to 7, we add 3. 7 to 10, we added 3. And 10 to 13, we added 3. So what we have here is we have repeated addition. So when we have repeated addition, that basically becomes our coefficient. So we're going to have 3 times n. Now, we do need to make this statement true so that if we plug in, for example, 1 into this equation, we get 1 as an answer. So we're going to have to do something to this to help us do that. So what we're going to do is so right now we know that 3n plus some number, we'll call it x, will give us this. So we need to solve for x so that we can get the actual rule. So what I'm going to do is I'm just going to pick one of the terms. So let's say I want to choose this term here. So this is our 5th term. So anywhere there's an n, I'm going to place a 5. And where the a of n part is, I'm going to replace it with a 13 because we know what the answer is there. So we have 13 equals 3 times n, which we know is 5, plus x. So we're going to solve to get x so that we can get the number that's added or subtracted to make the entire rule true. So we multiply that out. We get 13 equals 15 plus x. Then we subtract 15. We get negative 2 equals x. So we're going to replace this with a negative 2. So our rule is 3n. And then we're going to replace that plus x, and x is negative 2, so we'll say minus 2. Now you can check these, so like for example, if I plug in a 3 into this equation, I should get 7 as an answer. So if we do, 3 times 3 is 9, minus 2 is 7, which checks out, so we know that that works. Okay, so here we're being asked to find the general rule again. So I'm going to do the same thing I did last time. I'm going to put the term number below it. So first term, second term, third term, fourth term. Now, whenever we have fractions, sometimes it's easiest to kind of break it apart and write a rule for the numerator, and we'll write a rule for the denominator. So we need to see what's happening in the numerator. So going from one term to the next, we add 1. add 1, add 1. So if we were to write our rule, since we're constantly adding 1, that's going to be our coefficient of n. And then we're going to have to add some number x. This kind of looks like, make sure that it's a 1. And we're going to do the same thing for the bottom. So going from 3 to 4, we add 1, add 1, add 1. So here we have 1 in, and then we'll use a different variable. We'll call this one plus y. So what we're going to do now is we want to take some of this. So for example, we're going to take 2. So we're just going to look at the numerator part now. So we have 1n plus x, and it should equal 2. Now that's when n is equal to 1, so we're going to plug in a 1 here. So we have 1 times 1 plus x equals 2. I'm sorry, 1 times 1. So that's 1 plus x equals 2. So if we subtract 1, we get x equals 1. So for our rule, we have a of n equals, you can say 1n, or you can just say n, and then we'll put that plus 1. So we're going to do the same thing for the denominator. Let's see what color. We'll put this in orange. So we're going to look at just the denominator now. So we're going to look at like this 3. So we know 3 is equal to 1n. So 1 times n in this case was 1 plus y. So here 1 times 1 is 1 plus y. Subtract 1. We get 2 equals y. So in place of this, we're going to replace it with a plus 2. And then 1n we can just simplify as n. So this would be our rule. A of n equals n plus 1 over n plus 2. And again, we can plug in, like if we plug in a 4, 4 plus 1 is 5, which is what we got here. And if we plug in the bottom, 4 plus 2 is 6, which is what we have here. So it checks out.